today I'm going to be going over assignment 5. And so I do want to give a warning that basically I was running out of GPU on Google Colab, so I actually ran the 10,000 epochs somewhere else, and I'm going to be attaching that results. But I went ahead and did 100 epochs here just to give a base of what this code will output, and I will be showing both the 100 epochs and the 10,000 epochs. Alright, so first and foremost, I just want to go ahead and explain this code. So, as I was saying, I wanted to make sure I'm using GPU, so I print out the device and making sure that it's using CUDA instead of CPU. I printed it before just to double check what device was using. So, in that case, I was using GPU, so that was good. Alrighty. So, first and foremost, the purpose of this assignment is to use, basically we were giving class an MLP, and we're going to be translating into GNN using the GAN. And so with GAN, there's two distinct things that it has. It has something called the generator, and it has something called the discriminator. Now, with that in mind, I went ahead and created two classes of those. And so in the generator, we're essentially setting up the initial spatial size of 7. This basically sets the initial image size before upsampling it. So generator, typically it upsamples, and then it's going to be generating an image, while I'll explain later what's the discriminator's role. But the idea of the generator is supposed to create like a feature map that is like 7 by 7, and then scale up to 28 by 28. So that's what basically this line of code does. But this part, this convolutional layer, the aim of this guy is to, it's supposed to take up like a 100-dimensional random noise vector, and then it's supposed to then flatten the tensor, so then it can be reshaped into the 3D map. That's going to be the shape of like 128 by 7 by 7. And then we're going to be using the ReLU activation layer. So then we're going to go jump down to the forward pass function, where it shows how the data is flowing through the neural network. And so the aim of this line here, the out, it's supposed to upsample and actually refines the feature map and making it a 7 by 7, and then we're translating it to then 14 by 14, then we're converting it again to 28 by 28. So its final output should be a 28 by 28 image. And so we're using this tan right here. We're going to be using the tan function. Basically, just make sure that it's within the range of -1 to 1. And now the purpose of this line here is to pass the noise through the connected layer, and so then we can make it into a 4D tensor. And so the shape of that will be actually a batch size, whatever batch size we set it to, and then 128 by 7 by 7. And so remember what we were saying about the discriminatory part of GAN, or GAN. So the discriminatory, the idea of that is to help determine whether an image is fake or real. If it's real, the aim is supposed to go ahead and output 1 for real, and then fake will be output 0. Okay. So this is our forward pass, and this is us. This is the constructor of the discriminatory, and yeah. So the idea of it is that the CNN is supposed to receive that 28 by 28 image, and then just to see and distinguish whether it's real or fake. One thing I did mention, here's the activation layer is ReLU. Here we're using the activation of sigmoid. So yeah, and then the idea is that we're returning whether if it's real or fake. Okay, So let's just hop into some data processing. So here, this whole bunch of code, it just helps to prepare up the image, so that way when we're translating it, we are translating it from image into numbers, and then transforming all the image into the same size, same format, just to make it easier to compare. So in essence, that just basically means that we're converting those images to those pi tensors, so then we can normalize those pixel values from that normalized range of -1 to 1. Um, and this helps it to make it like compatible with the generator's output. And then now we're moving on to actually the data set and the data loader. So remember, now we're setting the batch size to 64. We're doing the setting the train set. This is just hyperparameters that we've set it. This is the data loader. And now we're initializing the models by calling those classes that we just mentioned. This is the loss function. These are the optimizer. We're using Atom as the optimizer. We're using the cross entropy loss function for the loss function. And then this whole thing right here, it is basically our training rope. Right now setting it to 100, but it's going to loop over each one to 100. It's going to for loop it. And so essentially the idea of this is basically we're just iterating through those batches, image in the data set. And so we're moving those real images to the device, and then we're creating those labels, whether if it's real or fake. Remember, if it's real, it's 1. If it's fake, it's 0. And then we're just computing its loss, which is what we're doing here, just, printing it out. So then basically, yeah, so we're then training here. You think we're printing it twice, or doing this twice, but actually we're just doing it one for the generator. We're training that, and then we're training the discriminator here. So we're just basically creating those random noises and then generating those images, and then we're going to train the generator to fool the discriminator into thinking that those fake images are real, so we can get a label of 1. That's the point of the generator. And then remember, the discriminator is just to take those images and really assign a value of 1 or 0, indicating whether if it's real or fake. And yeah, so that's pretty much it. I mean, it prints out the epochs, its loss, its discriminator loss, its generator loss, and then here we're just displaying the final output. So like after we train, the generator is using that 5x5 grid, and of those, like the new numbers from the noise, and the output would just denormalize from -1 to 1, and then also to 0 to 1 for just so we can see it. And yeah, basically we're gonna get this. Again, this is just after 100 epochs. After 10,000 epochs, we're gonna get something like this. And this was my image after 10,000 epochs. So yeah, and that is pretty much it. So before I end it though, I want to say like it did very well of if you can see, this is a 3, an 8, another 3, a 1, an 8. So it did really well of generating actual like numbers for this code.